Hello geometers, and welcome to the lesson on the properties of a kite. We've already talked about the definition of a kite, but let's just review it really quickly. It's a quadrilateral that has two pairs of consecutive congruent sides, but the opposite sides are not congruent. And in this video, we are going to prove a property of the kite. And we're actually going to prove this one first. Okay? If it's a kite, then exactly one pair of opposite angles are congruent. So let's start out with a nice picture here of the kite. And this is kite A, B, C, D. Okay. And using the definition, we know that the consecutive sides are congruent, so that means this pair that are touching are congruent, and then this other pair back here are congruent. But these two are not congruent to each other. So AD and CD cannot be congruent to each other. And what we want to do is show that angle B is congruent to angle D. And also that A and C can't possibly be congruent to each other. But we'll get back to that in a minute. So first, let's show that angle B and angle D must be congruent to each other. And to do this, we employ a very simple strategy, which is to take a shape that's new to us, in this case a kite, and reduce it or split it up into a shape that is very familiar to us. That would be a triangle. Okay? So if you look at these two triangles, it can be shown fairly quickly that these two triangles are congruent to each other. And I'm just going to write out all of the steps. AB is congruent to AD. That's given. BC is also congruent to DC. That's also given. Okay, so both of these are given. And then if you look at the segment in the middle, AC is congruent to CA. That's reflexive. So this is just saying that every line segment is congruent to itself. Let me write the word reflexive neater here. So finally, the two triangles, ABC is congruent to triangle ADC by side, side, side. Therefore, the two angles B and D must be congruent to each other by corresponding parts of congruent triangles are congruent. CPCTC. Okay, and there you have it. That concludes this part that shows that angle B and angle D must be congruent to each other. All it says here is that the two triangles are the same shape because they all have the same sides. So the two angles must also be congruent to each other. And I'm going to add an additional note here that it's very important that it says exactly one pair. So not both of these pairs. So angle A here, this is the original angle A, and angle C over here. So angle A cannot possibly be congruent to angle C because otherwise ABCD would be a parallelogram. Okay. And maybe even a rhombus. So, basically the opposite angles here, they are congruent to each other, but the other set of opposite angle A, or angle, I should say this more specifically, BAD, angle BAD cannot be congruent to angle BCD. Right? Because if they were, the shape would be a parallelogram. It would not be a kite. Okay, so there you have it. That completes the proof of theorem 8.19, the opposite angles of a kite. I'm going to actually continue this video and show you how this proof really does help us with theorem 8.18 here. Okay, so showing that the diagonals of a kite are perpendicular, so I'm going to draw in this line right here. So the goal here is for us to show somehow that angle 1 is equal to angle 2. So if these two angles are congruent, then they must also be 90 degrees. Okay? And I'll say this statement here. Since the measure of angle 1 plus the measure of angle 2 equals 180 degrees, because they are linear pairs, we need to show that the measure of angle 1 is equal to the measure of angle 2. Okay? So if they add up to 180 and they equal each other, they must be each equal to exactly 90 degrees. Okay? And that will complete theorem 18 here that says the diagonals of a kite are perpendicular. Okay? So from the previous theorem, from the previous proof, we've already demonstrated that triangle ABC is congruent to triangle ADC. And we can take it a step further and use this here, angles 3 and angle 4. Okay? So from the proof of theorem 819, triangle ABC is congruent to triangle ADC. Therefore, angle 3 is congruent to angle 4 by CPCTC. All right. Now, what we need what this allows us to have is a pair of congruent angles here. So we can say that these two angles here must be congruent to each other as well. Okay. And if you look at this picture, it's easy to see that BCE and DCE are congruent triangles. So I'll write this out. BC is congruent to DC. That was already given to us. Then we also have EC and CE. Because that's reflexive. All right. So finally, we can conclude, let me zoom out a little bit here, that the two triangles are congruent to each other, namely BCE and DCE. By side angle side. Okay. You have a side here, BC and DC. You have an angle 3 and 4, and then you have a side in the middle. And since those two triangles are congruent, then angle 1 must be exactly congruent to angle 2 by CPCTC. And that pretty much completes the proof. Because if angle 1 and angle 2 are congruent to each other, and they also add up to 180 degrees, then they must be 90 degrees. And I'll leave it to you to actually finish out that step, but we have theorems already in the past that will show that this is true. So there you have it. Thank you for watching. As always, if you need help, please ask for it. Keep working hard and have a wonderful day.